Okay, it's time to look at some voltaic cells. If you'll recall from our discussions of electrochemistry, the voltaic or galvanic cells are the ones that are spontaneous. That is, we don't need an external power source. We're just going to read what potential exists between our two solutions. So what I have here initially, on the outside of this little pot in the middle here, the clear solution is zinc sulfate, 1 molar zinc sulfate. That's this solution here. Inside the pot, if we look over the top, you'll see this bright blue solution. That is 1 molar copper 2 sulfate. Now, hooked up to my voltmeter, I have a zinc electrode attached to the negative anode and a copper electrode attached as my positive cathode. I'm going to match the copper to the copper solution and the zinc to the zinc solution, and we are going to read the potential off of the screen on this computer. Now, if you look up at this computer initially, our potential, which is a little hard to see initially, is reading 0. Right now there is no potential going on here. As soon as I place this in the solution, we're going to see that change. So I'm going to submerge my electrodes, and let's take a look. The potential has now drastically changed. We now have a potential. So in our new assembly, we are not going to use the copper electrode anymore. Instead, we're going to exchange this for an iron electrode. In the clay pot that we have for our salt bridge, I've placed an iron sulfate solution, which should be described in your procedures for this lab. So I am now connecting the iron with the alligator clip, and this is now connected to our voltmeter. And it's only when we finally submerge the solution in, or the electrodes in solution, that we'll get a potential. So initially we saw that the potential was 0. We're going to submerge these, again match the iron to the iron and the zinc to the zinc on the outside, and submerge these electrodes, and voila, we have a potential. Now there may be some drift if we have a little bit too much contact with other electrodes, or if that salt bridge is touching things it's not supposed to touch. So we're going to adjust this ever so slightly. Try and make sure that we have a nice setup. And now our potential should stabilize. Not too bad. So now let's set up the next one. So now we're going to do an iron and copper cell. So I'm taking the zinc electrode out. I'm going to replace it with a copper electrode. This is just to hold the electrode in place so it doesn't wiggle around too much. This is what actually connects it to our voltmeter. Now in here, I've got my 0.1 molar copper solution again, and on the outside I'm going to pour some of the iron sulfate solution. Being careful not to add it to our pot in the middle. Again, this porcelain thing is acting as our salt bridge. It's a porous material that allows for the flow of ions. Again, we are going to match iron to iron on the outside, copper to copper on the inside. And again, if we initially look, the potential is 0. And once we have submerged our electrodes, might need to wiggle things around a little bit to get things in line. Once we've got that submerged, we have a potential. Now, you'll notice that this is coming out negative. This is because when we set this up, we're actually supposed to have the iron as our anode rather than the cathode. So let's take a look at our voltmeter. Notice how I've got this attached to my positive terminal. This, with a Voltaic cell, is going to be the cathode. I don't want my iron to be the cathode here. I want it to be the anode. So what I'm going to do to fix this is simply switch the connections. In our setup for the cell, the iron should be the anode. Now we see the potential coming out positive, as we would expect for something that is galvanic or voltaic. Let's move on to the next one. Now for our last setup, we're going back to our zinc and copper. So we still have these electrodes again. And again, the copper is going to be our cathode, and the zinc is going to be our anode. Now, in this case, though, we're not going to be using a standard state electrochemical cell. Instead, we are going to be filling our little pot here with 0.1 molar of our copper sulfate. So instead of using the 1 molar solutions like we did with the others, this is going to be 0.1 molar. So again, in this jar, I have the zinc sulfate solution, the 1 molar solution, and inside here, I have 0.1 molar of our copper to sulfate. I had a little bit too much. That's okay. There we go. Okay. So I've refilled a new pot with the 0.1 molar copper sulfate solution, the copper 2 sulfate. So notice that it's significantly less intense blue. That's because it's a more dilute solution. And again, this is not going to be a standard state electrochemical cell. We're going to use the Nernst equation for this one. So I'm going to put my electrodes in place, and let's take a look at that potential. Note that it's a bit different than what we saw when we had a standard state cell, which we should expect. It's not a standard state cell, we get a different potential. And that pretty much wraps it up for our Voltaic lab.